Hello, in this video we're going to review a very influential proposal about how the mind is organized. This proposal is due to Jerry Fodor and was popularized in his 1983 book, The Modularity of Mind, which is one of the all-time classics in cognitive science. We could see Fodor as trying to answer the question, what is the functional organization of the mind? Notice that he's not asking about anatomical organization. He's not dealing with the parts of the brain, for instance. Rather, his inquiry is squarely within the computational theory of mind. So he is asking about whether the mind can be understood as having computational systems and subsystems, and if so, well, what are the characteristics and how are they related to each other? This question about the functional organization of the mind can be elaborated further. So we can ask, how homogeneous is the mind? How much internal differentiation is there? And to the extent that there is internal structure, on what principles is it organized? So what Fodor is trying to provide is an overall image of the architecture of the human mind, which will include a model of the general organization of the mind. And this will encompass a list of the main components in the mind, as well as an account of how information is processed in those components. So going back to our question regarding homogeneity, one way of posing it is by asking, is our cognitive system just a general purpose information processor? One possible extreme view says, yes, it is. In this view, the cognitive system would have the same basic operations everywhere, and an account of cognition would deploy the same primitives in the same explanations of all sorts of phenomena, and the same generalizations would apply across the board. Under this view, our cognitive system is functionally undifferentiated, again, homogeneous. So exactly the same kind of information, or similar, happens everywhere. The same kind of information processing. Again, under this view, we have the same basic principles applying to different capacities. A historical example of this would perhaps be the classical British associationists. Notice that I say perhaps. So they propose that the basic unifying principle underlying the variety or apparent variety of mental phenomena is the association of ideas, and that all that there is to perception, memory, imagination, and the other phenomena is, well, ideas being associated according to the principles of contiguity, resemblance, and causality, for instance. Right? That applies to, again, explaining music, language, perception, social inference, anything. In any case, what we have is the same kind of general resource being deployed for particular tasks. There is no internal specialization to speak of. And this is what is depicted in this diagram. Exactly the same cognitive engine applied to all sorts of capacities and tasks. Now, this is a view that hardly anyone holds, but it's good to keep it in mind because it is a good contrast with Fodor's view. So most researchers, I think, would admit that there is some degree of internal differentiation in the mind. So the question is, what are the main lines along which the mind is divided? Here we can find two opposing views. On the one side, there are those who think that the mind is divided according to the content of the information being processed. For instance, some subsystems would deal with basic visual stimuli. Some would be specialized for the processing of faces. Some other would be devoted to the processing of speech, so on. The opposing view says that the mind is organized not around kinds of contents, but around the different kinds of processes it carries out. So you have a division among perceptual processes, learning processes, memory, attention, etc. This seems to be the more traditional or the more standard view, and it's probably what you find in most introductory psychology textbooks, where you have a chapter for sense perception, another one for attention, and so on. The first type of organization by content, is what Fodor calls vertical organization. And the second, organization by process, is called horizontal organization. A couple of words about horizontal organization. So this is the view favored throughout much of the 20th century. According to this position, the mind contains a series of domain-general, all-purpose processes. So we're saying domain-general in that we have, for instance, the same central resource, say a suite of learning mechanisms, which is deployed to different tasks, from playing chess to riding bicycles to checking whether someone is lying, for instance. So here you have a diagram which depicts a cognitive system with pure horizontal organization. The mind contains a series of general purpose mechanisms or processes which again are applied to different tasks. So for instance, general purpose system 1 could be a set of memory processes. General purpose system 2 could be a set of learning procedures. General purpose system 3 could be the organism's general attentional resources. So capacity 1, on the other hand, might be playing the cello. Capacity 2, might be deciding where to invest your money. And capacity 3 might be understanding sentences, and capacity 4 might be tying your shoes. So what this diagram tells us is that the same memory, learning, and attentional systems would be recruited in different ways, of course, to deal with tasks as diverse as tying your shoes and making investment decisions. And what about pure vertical organization? Under this view, for each of a relevant subset of our different cognitive capacities or tasks, there is an autonomous, dedicated system. And so each of these systems has its own representational types, databases, and operations. In this case, rather than consisting in a set of general purpose tools, the mind would be comprised of domain-specific, special-purpose processors. This diagram illustrates a system comprised of a series of subcomponents, each devoted to a given capacity and endowed with some special purpose resources and mechanisms. So, for instance, the first box might be a system devoted to face recognition. The second would be a system for linguistic processing. The third would be for attributing mental states to people. The fourth would be for detecting geometrical relations, etc. Also, notice that there is no crosstalk between these systems, and that each of them has its own proprietary body of information and algorithms, for instance. So that the primitives employed by the language capacity may be very different from those of the geometrical capacity, for instance. Now, Fodor thinks that for certain very important parts of the mind, the vertical approach is the correct one. So, what does Fodor propose in the modularity of mind? To start with, Fodor distinguishes three different kinds of cognitive systems. The first and more peripheral ones are the transducers, which have the job of translating physical stimuli into a format that can be used by the brain. Now, Fodor does not devote much space to transducers, so neither will we. Rather, his emphasis is on the last two. The job of the input systems is to get information to the central processor. That is, they mediate between transducer outputs and central cognitive mechanisms. In this group, Fodor includes the sensory systems, and interestingly, the language processing system too, and that is an input-output device. That's how he conceives it. Finally, we have the central system, which is in charge of establishing beliefs about the world and drawing inferences on the basis of these beliefs. Fodor thinks that the input systems have characteristics that set them apart from the central system in quite significant ways. In fact, he says that input systems, unlike the central system, are modular in nature. But what is a module, then? In the modularity of mind, Fodor does not propose a definition of a module. Rather, he is interested in identifying a natural kind, that is, a non-arbitrary category to which a systematic body of generalizations would apply. So what Fodor says is that a cognitive system is modular to the extent that it exhibits the following characteristics. First, modules are domain-specific. This means that they tend to be specialized for one particular kind of information. This is a very important property, and we will discuss it in more detail later on. Second, we have mandatory operations. This means that modular processes will apply whenever they can apply, whether you want it or not. So if you open your eyes, you can't prevent your visual system from presenting you a scene, and you cannot force yourself to perceive only shape, but not orientation. Moreover, if someone speaks to you, you can't help but hear the sounds they are emitting as language. Try as hard as you may, you cannot sidestep the linguistic aspects of the stimulus and simply hear it as a series of noises. So one of the things that Fodor says about modules is that they're a bit like reflexes. So if somebody draws their fist close to your face as if to punch you, then you quickly and involuntarily close your eyes. You don't deliberate about the whole thing, weighing the pros and cons of closing your eyes. Well, the same happens to modules. They operate whether you want it or not, right? And in this sense, they're a bit like cognitive reflexes. Also, central systems have little or no access to the information inside the modules, so that from the central system point of view, modules are black boxes, so to speak. So more about this in a moment. Fast processing is something that also characterizes modules in Fodor's view. So think about how long it takes you to understand the sentences I'm uttering or the visual scene before you. It takes you in the order of milliseconds, which is almost, it seems instantaneous, especially when you compare it with, say, conscious problem solving. Modules also tend to have a limited accessibility to the central system. This means that they operate according to their own processes and information and can't make use of information that is centrally held, such as beliefs. Again, we'll take this up in a moment. They also tend to have shallow outputs. For instance, what a parsing module outputs to the central system is a mere sketch of the structure and overall content of the sentence you are hearing, rather than an elaborate, precise, and fully worked out interpretation. Something similar would be said of the early visual system, for instance. So a visual module could deliver the content, "This is a square," but not the content, "This is an instance of a German expressionist painting." And a module can output the recognition of a face, but not the content, "The all-time youngest chair of the history department." Fodor also speculates that many modules may have a fixed neural architecture, though he doesn't put much emphasis on this. He also says that when modules fail due to injury or illness, they don't malfunction in random ways, but rather exhibit specific breakdown patterns. So, for example, we have associated with the linguistic system a series of aphasias, and damages to particular subsystems of the visual system manifest themselves in characteristic syndromes, such as the different kinds of agnosias. Finally, modules show a characteristic ontogenetic pace and sequencing. Ontogenetic means related to the development of the individual. So what Fodor is pointing out is that modules tend to follow specific developmental paths and timelines.